Chapter 10 Mechanical Waves and Sound Wave. 10.2 Superposition of Waves. At the end of this chapter, students should be able to state the principle of superposition of waves for the constructive and destructive interference, discuss progressive waves and stationary waves. Superposition is a process occurs when two waves of the same type meet. Principles of superposition states that whenever two or more waves are traveling in the same region, the resultant displacement at any point is the vector sum of their individual displacement at that point. The diagram shows reinforcement and cancellation. The diagram shows superposition of waves when t equals to 0, t equals to t1, and t equals to t2. Interference can be categorized into constructive interference and destructive interference. Interference happens as the interaction or superposition of two or more wave motion. Constructive interference happens when the resultant displacement is greater than the displacement of the individual waves. It occurs when y1 and y2 have the same wavelength, frequency, and in phase with each other. Destructive interference happens when resultant displacement is less than the displacement of the individual wave or equal to 0. It occurs when y1 and y2 have the same wavelength, frequency, and antiphase, or out of phase by radian between each other. The diagram shows constructive interference and destructive interference. Constructive interference, as can be seen, is the resultant displacement is greater than the displacement of the individual wave. So y equals to y1 plus y2. Destructive interference is when the resultant displacement is less than the displacement of the individual wave or equal to 0. Standing or stationary waves. Standing waves is when waves with equal amplitude, wavelength, and frequency traveling in opposite directions in the same medium are superimposed. It is a form of wave in which the profile of the wave does not move through the medium. Example of stationary waves is when plucked string progressive waves, then the end of string reflected back, incident plus reflected wave will superimpose, next stationary wave fixed node and antinode. As can be seen, standing waves is when waves with equal amplitude, wavelength, and frequency traveling in opposite directions in the same medium are superimposed. It is a form of wave in which the profile of the wave does not move through the medium. Example, consider a string stretched between two supports that is plucked like guitar or violin string as shown in figure 10.3. What will happen is, when we pluck the string, progressive wave will be produced. Then, at the end of string, the waves will reflect it back. So, incident plus reflected wave will superimpose. Next, the stationary wave will have fixed node and antinode. Node is a point at which the displacement is 0, where the destructive interference occurs. Antinode is a point at which the displacement is maximum, where the constructive interference occurs. Characteristic of stationary waves. Nodes and antinodes appear at particular time that is determined by the equation of the stationary wave. The pattern of the stationary wave is fixed, hence the amplitude of each particles along the medium are different. Thus, the nodes and antinodes appear at particular distance and determined by the equation of the stationary wave. From the figure 10.4, the distance between adjacent nodes or antinodes is lambda over 2. The distance between a node and an adjacent antinode is lambda over 4. Lambda equals to 2 times the distance between adjacent nodes or antinodes. Equation of stationary waves is y equals to a cos kx sine omega t, where a cos kx determines the amplitude for any point along the stationary wave, and the amplitude formula. Its value depends on the distance x. Sine omega t determines the time for antinodes and nodes will occur in the stationary wave, where a equals to amplitude of the stationary wave, where a equals to 2a, and small letter a is amplitude of the progressive wave. The difference between progressive and stationary waves. Progressive wave have wave profile move. Stationary wave profile does not move. All particles vibrate with the same amplitude for progressive wave. For stationary wave, particles between two adjacent nodes vibrate with two different amplitudes. Neighboring particles vibrate with different phase for progressive wave, and in stationary wave, particles between two adjacent nodes vibrate in phase. All particles vibrate for progressive wave. For stationary wave, particles at nodes do not vibrate at all. Progressive wave is produced by a disturbance in a medium. Stationary wave produced by the superposition of two waves moving in opposite direction. Progressive wave transmit the energy. Stationary wave does not transmit